to say, after this, we're going to go to cask. Saskia reminded me 3 times that we are going to cask afterwards. So I'm going to remind you 3 times that we're going to go to cask. It's optional, but it's just kind of nice, social, relaxed, and looking one inside of the building. So we do have to leave at some point. So we're going to cask afterwards. There we go. I said it 4 times. And up next, Gerald, who's going to talk to us about denial of service and precision munition. Okay. You got to stand like here so Tim gets you. Okay, here you go.
Right, can everybody hear me all right? Okay, so I've tried to come up with the ponciest title possible, and I think Precision Munitions for Denial of Service has done just about that. I would also like to say my imposter syndrome has properly kicked in about 2 minutes after Katie started talking. You know, she dropped names more than microphones. Yeah, I really enjoyed that, so yeah, prepare to be disappointed for this one. So, something about me, apart from the fact that I've got a nice knitted figure, I'm old and grumpy, maybe not as old as and grumpy as some. I remember Java 1.0. I used it, I wrote in it, and yeah, so I didn't have a long and varied career as a maker of software, with some boring companies, some not so boring, and then I found so many issues in a certain high-profile tax collecting agency who should remain nameless, that they said, Gerald, don't you want to do a bit of AppSec for me? Now, one of the things that working in banks has taught me, and a very good friend of mine once told me this anecdote about, he went into the server room when, you know, banks still had those, and he saw a network router suspended in midair between 2 sides of a cabinet, held up only by the network cables, and he was told that it's not something that can ever be touched. Now, banks are not alone in this kind of way of doing things. I once got told a story about a certain mainframe that was in HMRC, where they had a flood in the office, which meant that the floor gave way, and again the mainframe was suspended by the cables. Now, when the contractors came in to try and fix it, they obviously said, well, you know, can we just unplug it, build the floor? And said, no, we can't unplug it because this is critical national infrastructure. So they had to prop it up, build the floor underneath it, and then leave it there. It's probably still in operation. And probably hasn't been patched, except obviously for the floor tiles. So yeah, over my career I've worn many hats. It's very useful to be a developer, architect, DBA, to then sort of try and find out the context. Now, in this talk, I'm going to be talking about denial of service. Now, not the distributed kind, so not the kind where you send lots of requests to a service to try and overwhelm it. I'm going to be talking about doing precision strikes. Here's the Ponzi title again. And I'm going to use the play framework as an example, mainly because I've found some stuff in it. And I'm going to be talking about something that I've called automatic amplifications, which is really interesting. And then I'm going to try and see what can help us prevent those kinds of attacks, and some lessons. So distributed denial of service. The in-joke here is the low-orbit ion cannon. Obviously takes its name from Star Wars, which is, you know, when you do a distributed denial of service, you send in the Imperial fleet with all the Star Destroyers, bomb everything in sight, and the stormtroopers still can't hit anything, while our friendly neighborhood rebels fly in with small craft and deliver a precision target and destroy the Death Star. I'm going to labour this analogy a little bit longer, so bear with me. So one of the things to sort of think about in modern infrastructure, you don't just have a single application that is sat somewhere deployed in the cloud or in a data center or, God forbid, on your local laptop. You usually have got content delivery networks, you've got web application firewalls, you've got load balancers, you've got hundreds of proxies sat in front of it. So in order to deliver something that can impact, that can deny the service of a particular thing, you have to navigate that, yes, Star Wars trench to get to the exhaust ports to, yeah, you get the picture. So this is what I want to talk about, and this is really interesting. I found it fascinating to hear Katie talk about all the different attack vectors in APIs, and she saved me a job introducing JSON. Now, this vulnerability is one that I found. The play framework was able to be attacked by having a payload that is valid JSON, has got a single field, but the field contains an array, which contains an array, which contains an array, which contains an array, which has got a single element called 0. But what you have to imagine is that there are 30,000 of those opening square brackets and 30,000 of those closing square brackets. And when the play framework was trying to process that, it just fell over. It wasn't able to handle the fact that there was a deeply nested structure. Now, interesting thing, before I came here this afternoon, I hadn't actually realized that I'd met Saskia about, God knows, 8-7 years before, where I delivered a talk on denial of service using XML. I went through a lot of sort of XML things. So and one of the questions at that talk is, can you do this with JSON? Well, yes, now I can. So, yes, well, it took me a while, but hey ho, I got there. So basically, you send a payload like this to something that is a play framework, it falls over. Now, the interesting thing when it falls over is that it returns a HTTP status of 503, which is essentially, it's not available. And in our instance, that lovely infrastructure that we had that protected us from all the distributed denial of service attacks, the web application front, all the load balancers that make sure that our systems is properly distributed. When it gets a 503 back, it goes, oh, this request has failed. There must have been some problem with the infrastructure. I'll just send it to the next instance. So a single request blows up instance number 1, then blows up instance number 2, and then blows up instance number 3 because the infrastructure automatically resends that malicious payload. After 3 tries, in my example, it gave up because usually it has got retries defined. So it's interesting that you can send a single request and blow up 3 servers. Now, you think, well, the kind of infrastructure that we've got these days, we're all self-healing. We have auto-scaling groups, we automatically restart our things, and it's not a problem if a few things fall over. Now, this snippet of bash sends that malicious request, sends one every 10 seconds. Now, you have to think, is your infrastructure going to be quick enough to restart those instances after every 10 seconds? I remind you that one request kills 3 of them. That's what you end up playing. You're playing whack-a-mole to sort of take down lots and lots of instances. So it's really interesting to think about that. You think about modern sort of cloud-provided things, you go, oh, we've got auto-scaling. But actually, instances don't come back up instantly. Usually you've got you've deployed a fleet of them. The infrastructure will have some code in it that checks whether something is still alive, but it won't sort of bring something up again if one health check fails. It usually says that, oh, I'll check 3 times to make sure that it's properly dead. because otherwise, if there's a little networks comps problem, you might kill an alive instance. So the reason why this gets interesting is simply because the time it takes to bring up an instance. Now, what you have to think about is, what if those instances are running your login system? What if I come along with my puny number of requests and take down your login page and none of your users can log in anymore? Doesn't take a lot of requests either. So next one, obviously, going back to my initial thing, we've got web application firewalls. These are things that you pay lots of money to AWS for, or other cloud providers are available, that sit in front of your infrastructure that protect you from malicious attacks. Now, the thing that may not be always obvious is that these web application firewalls don't inspect the whole of your payload. They typically inspect the first 8 kilobytes or the first 16 kilobytes. So if I look at my malicious payload and put a very long string in front of it, that is like 8,000 or 16,000 characters in length, then the web application firewall will not see the malicious payloads that have sneaked through. Now, this is often very interesting and important because the default configuration of the Play framework was that it deals with requests of 100 kilobytes. So you've got that slight variance, and nobody ever looks at those and says, oh, I'm going to optimize my thing to reject payloads that are greater than a certain size, because that means when some new feature comes in that requires bigger payloads, suddenly everything stops working. The other interesting thing, I should have mentioned this before, is that what makes this really interesting with the Play framework is that the Play framework itself reacts to these JSON payloads based on the content type. Even if you create your software that only wants to deal with, God forbid, XML, or just URL encoded post request, and never is designed to deal with JSON, if you send a content type of application JSON on one of these things, the framework itself will try and convert it into something else and falls over. So even if you think, I don't deal with JSON, this isn't a problem for me, in the case of the Play framework, yes, it is a problem for you. Now, the third one, surely all the dependency scanners will save us. We've got security teams, we've got the latest great software from OWASP, obviously, the dependency scanner, great stuff. Other tools are available. And this has been mitigated. So, I've raised this with the Play framework, the Play maintainers raised the thing, and it was mitigated within a couple of weeks. Response time, considering that the Play framework itself is now a community-led project, has been quite amazing. Now, the problem is, this vulnerability is a denial of service vulnerability. So unlike the sexy Log4Shell vulnerability that allows you to inject code and achieve remote code execution, this vulnerability will only ever deal with, Katie, I think it was number 4 or 5, the resource allocation. So it's not the maximum score that it can get in a CVE. I probably should have explained that CVE stands for Common Vulnerabilities and Exposures, and it's a list of things of problems inside software, vulnerabilities. And every, I'll save my rant about CVEs for a little bit later, I think. So the maximum score is 7.5. It's a score from 0 to 10. There's a formula. Depending on the kind of things that your vulnerability has been identified as, it goes and assigns that score. Now, when you buy these lovely products from vendors, they tell you things like, oh, and it's great, you can put it into your build pipeline, you can configure it with policies that ensure that your vulnerabilities won't get through to build, so you're safe. The problem is there's so many of them. Actually, that's a different slide. There's so many of them, so even if you've got just a few applications, you very quickly end up with hundreds of reports. So typically, organizations say, oh, well, we have a policy of you need to fix every vulnerability of greater than 9 within 48 hours and every one greater than 8 within 72 hours, and then we don't care much more. So it's interesting that this denial of service thing might just slip through your policy. You might decide, like some vendors recommend, you set your policy at anything over 8 needs to be dealt with, which basically means anything under 8 gets ignored. So these are some other interesting patterns about what can cause denial of service. Now, this is it's one reason why I like XML so much, and I think I probably used this in my talk 8 years ago, but it still works. And this is based on hash collisions. So when you send a payload with lots of elements that look like this, they all have the same hash code, which means that when the software processes it, it does it very inefficiently, and you can basically make a CPU busy for hours. And the interesting thing is, when you look at the vulnerability databases, this is a CVE from the year 2012. But when you look at who's using it, it's still being used. There's lots of vulnerabilities out there that can cause denial of service, because I think it's something that doesn't get the same sort of press as remote code executions. Therefore, it's sometimes ignored. It's also very often specifically excluded from vulnerability, from HackerOnes. I've seen where it's like, oh, we don't deal with denial of service. But if you consider that you can take down your whole website with a few requests, you probably should pay attention to it. So this is what happened when I put one of those requests through. This is what happened to the CPU usage. And if you do that often enough, you take something down. Other ones that I like are YAML bombs, the billion laugh XML XXE problems, a zip bomb. One of my favorite is irregular expression denial of service, because they tend to have a score of 5.3. And if you find one of those, you can still take up all the CPU of a service, do it often enough, nothing responds anymore. I've got no idea how I'm doing for time, so I'm just going to go on, waffle.
You're doing pretty good for time, to be honest. Yeah, you've got loads of time.
Some more for questions, brilliant. So one thing, I work as AppSec in that unnamed, well-known tax agency of the UK. HMRC. And this here is a, well, almost intentionally very badly drawn graph. I don't want you to see the actual words that it says, but this is all the interconnectedness of the services. I look after something like 1,000 microservices. So finding a vulnerability in 1, 2, 10, 20 services, it's doable. But it's the scale that makes this a problem. And this is what happened when this is when I started ranting about CVEs. This is when a tool called X-Ray, which gave us all the vulnerability reports across all the artifacts that we had across our estate. And I had 800,000 of them. I'm not going to really be looking at them all now. I've got 70 teams. 70 teams aren't going to look after those. And those are developers that have got pressures from the business owner to deliver features to, we don't have time for this tech debt security thing. Let's not do it because we need to deliver this. We've got deadlines. And I feel for them. I really feel for them. When somebody says, hi, I'm from security, it's like, oh shit, Gerald, what do you want to know? And it's a real problem. Now, one of the ways, and I'm going to get to some slightly more optimistic things, one of the ways that I think helps with sort of doing that, if you have 1,000 microservices that all use a different framework, all use a different architecture, then yes, good night, you're fucked. But if you have a platform and if you've got an opinionated way of doing things, if you want to do things in certain patterns, I think you have a chance. I don't know what slide's coming next. Yes, so what I did with those 800,000 reports, I put them in like a curation pipeline because I wanted to read all those 800,000 reports. Now, there weren't 800,000 different CVEs. There was about 800 of them. I read them all, I evaluated them, I compared them against the patterns of use that we were using, and it turns out that a lot of them didn't apply. It's like there's vulnerabilities in login frameworks that can only be exploited if you run them against the message queue, which no sane person ever does. And we don't. So this was a vulnerability of class 9.8, and I said, ignore it. We have got polymorphic deserialization issues where you take a bit of JSON, and if you can pass in a class name, it will bring up run some code for you. We don't use it that way. I've got CVs of 10. I'm telling people, ignore it. Please don't fix it. Please don't waste your time on looking at it. And I think since I drew that picture, we've sort of taken it one step further, and we've got like a service catalog. And the assessments that as an application security team we do, I put those assessments in so that the teams can self-service, can find out what are my vulnerabilities, what is the assessment, and what is the risk. Because just because something is a vulnerability doesn't mean that you're vulnerable. Let that sink in for a couple of minutes. Yes, I've gone a bit weird with my graphics. Now, this is the model which I think application security probably needs to have a look at. There is no such thing as a security team that can fix your security. All vulnerabilities depend on context. If you go in and say, oh, we've got this vulnerability, if you don't understand how the service is being used, you've got no chance. If you see something is using an XML library, but it's brought in as a transitive dependency that is never even used, how are you supposed to know that? The best thing is, go low tech, talk to people. It really works. If you can establish a rapport with the teams that are looking after those services, if you can make them aware of the issues, if you don't act like some wizard that lives in an ivory tower that comes down at the very end of the software development life cycle and says, no, you shall not pass. It's not going to work. People are just going to tell you, oh, fuck off, Gerald. So, to the lessons learned. Denial of service, I think, needs to be taken very seriously. I think it's a little bit of a forgotten book class. When you look at your own services, try to think about, well, what content type does it process? Could it process something that I'm not even aware of that it might process, which then leads it to whole new paths of executions? I'm afraid, I think, you're going to have to look at all the vulnerabilities that your vulnerability scanner tells you. Even the ones with a really low score. Don't ignore them because, like I said, DoS ones at 5.3. It gets even worse. You might even have to look at the code that the teams are writing because that's usually got more bugs in than your dependencies. Scale is a problem, collaboration helps, and having layered defenses, as in, you do want to have that WAF, you do want to have those defenses. They help, but it's a thankless task, and you have to do it. So, questions?
So you're talking about curating your CVEs and your vulnerabilities, and I was just wondering how much effort it was to sort out the tooling, because quite often when you've got a CI/CD pipeline, it's red-green. Okay, yeah, you've got a red problem. Maybe you're lucky enough and it's quite easy to fix all the reds, but maybe it isn't. You know you're vulnerable, as you said, but how do you automate the process of saying, now that was all right?
I'm going to go and bet on my other hobby horse, which is agile software development. I think you have to go full-blown agile on it. You kind of say, what I did with that vulnerability curation pipeline, I put something in there called spreadsheets. I basically made a big spreadsheet to start with. I wrote a script that talked to the API of the thing to just pull it all out, and then I did a bit of data transformation to just get a grip on the sheer number of it. Because I don't know whether there's anyone here with an affiliation with X-Ray or JFrog. I'm sorry, X-Ray is shit. Not as a detection platform, but the UI. Unless you have one of those. Have you ever seen this film Swordfish, where they have a bank of 9 monitors, and those are the really elite hackers? Unless you've got one of those, you can't use the UI because it is all so tiny.
So you basically need 9 monitors to be able to use it. That's like your lower benchmark.
Yes, absolutely.
Okay, just so I know.
Yeah. You get that report and it gives you, oh look, you've got 190,000 pages, and it's like, well, why even tell me? And then each of the columns is so small that you hover over each of them to actually get to see what it says. Maybe I should use a bigger laptop, but I think that's
Or
big
have
enough.
smaller eyes. Just have smaller eyes.
Yeah, fixed it. Brilliant.
Hacked it for you.
But yeah, so yeah. But essentially, it's very low tech. It was a bit of scripting, a bit of taking JSON out, processing it, turning into a CSV, and I had my big Google spreadsheet. All the spreadsheets are available. And I love pivot tables. They can tell you so many things, especially at scale, because remember, if you have 20 services and you look at all of them, it's possible. When you have 1,000, it's not possible. And it is about finding those patterns. It is about finding where you need to look. Because you can't look at, I think we've got 4,000 repositories and know where everything is. You need to have help, and that's where this sort of automation comes in. And once you've proven that out, that you can do that, then you can write a better, then you can improve that tool. Maybe these days you get service catalogs in like tools like Backstage. Can integrate things relatively easily, which then surfaces it to the developers, who can then look at it. And then you can take a shotgun and force them to actually look at it. Maybe that was a bit too violent.
In the corner, Gerald.
Sorry, yes.
So if you could offer us one tip to make developers care about all the shitty vulnerable libraries that they're importing into their software and packaging and shipping to customers, what would that be?
The one tip I would say is that as security, you have to have some sort of understanding what the developers are doing. I don't think it should be on a developer to know all the different vulnerabilities that weird people like me find. They shouldn't have to go and be glued to InfoSec Mastodon to see, oh, there's this vulnerability, and that looks interesting, that looks interesting. I think it really benefits from having that capability, even if there is like a security champion program that are interested in that kind of thing, and that get the time to sort of go digging, and that can then sort of say, this is not relevant, no, not relevant, and oh, this is interesting, let's have a look at it. Let's sit down with developers to sort of go, well, explain to me how this code flows. and then sort of say, well, and if you do this, then you could exploit it. You know, all the random button clicking that Katie's doing, basically that, but a bit more targeted, because if you have somebody sat there that actually developed that API, it gets so much easier because they can tell you, oh, and then it does this, and then it does that, and you can kind of say, all right, I'm not interested in this bit, but this sounds interesting. And I think as a sort of blue team, or as sort of application security, it is a lot of legwork, but I think it is important to have that context, that understanding how something is used before you can make judgments on how you stop developers. You have to, I'm sorry for the buzzword, shift left. You have to take your security left, you have to secure by design.
Oh,
There
come
was
on,
a-
Jack,
there was another one.
Bake it in.
Yes,
Bake it in.
There was a
We all
different.
have baked it.
There was a different buzzword that I thought of the other day. I can't remember it. I'm sorry. I failed.
Thank you.
Have you tried, when you're carrying out a DDoS attacks or trying to exploit the...
It's not DDoS.
DDoS attack, sorry. When you're carrying out a DDoS attack or trying to exploit some of these lower CV vulnerabilities
Yes.
that are getting through, have you tested any protections like RASP elements or anything like that in the web service?
Sorry?
A RASP element.
RASP.
Runtime application security.
No, I haven't.
So that runs inside the web engine and detects CVE, no CVEs being exploited inside certain DLLs. So
I think
I've
that.
had a bit of success with it.
I think
it's
that's
a really good security tool.
I think that definitely sounds interesting. I think I suffer from the fact that we use Scala, and some of the tooling around Scala, unfortunately, isn't as mature. But yeah, essentially, I would say any piece of tooling that you can get your hands on, and that doesn't cost you arm, leg, your children, is probably worth having a play with to see what it gives you. And that's what I mean by sort of layered defenses. You know, even though you can bypass a WAF, you still want a WAF. Even though this tool won't find everything, you still want it because it stops some stuff. And the more difficult you make it for attackers, the more likely they are to go, you know what, sod this, and going and attack somebody else.
Yeah. Totally.
Very interesting. Shift left, I think, is now called start left, because
Yeah.
you need to start security at the design, not after the effect.
Yeah, but the tricky thing comes in when you think that, but I'm agile, I'm continuously designing and starting, and so it's not like we no longer do software as waterfall, so we can't start with security and then take it all the way through. Anyway,
Okay.
I'm being facetious.
I'm now going to jump on a slight chronicles. Agile is fine for new software. Your little tax office has got lots of legacy software.
Oh yes,
Most people don't know what's in it,
yes,
how it's been built,
yes,
who wrote it.
yes.
So how are you actually, the lessons I would want to promote is how you curate the older software, because that's probably where the vulnerabilities are like to be, because you've no idea what's in there.
Yep.
All this stuff is probably fine for your X-ray and find nice model stuff, but you've got a lot of stuff that isn't known, that's probably
Yep.
protected by
Now,
tools, because languages like C and C++ are poorly supported, unlike the new ecosystems of your Pythons and your Javas and whatever. So how does what you're doing?
Now,
line
I used to work at a program that took 15-year-old code out of a data center and put it into the cloud. And it was a lift and shift. We couldn't rewrite it with all the nice things. We took it and basically went, does it work the same way as it did on the old kit? If it had the same bugs, fine. But what we did was because we were running the thing, we had a vested interest in knowing how it works, in knowing how it was secure. I mean, to a certain extent, it's dating back to a time when I was still a developer. I was looking after the thing. But I was interested in how things work, and then going in and trying to, oh look, it does this, it does the next thing. I would collaborate with security to say, oh, I found this thing. Could this be a problem? How could this be exploited? Oh, you could be doing this. unfortunately, I think legacy software, and I've got a whole talk about this, I love legacy software. It teaches us really important lessons, and not everything is bad. If you think about all the banks and insurances and things, the stuff that makes the money is that old tin. So it is important to have an awareness of this, and it doesn't matter whether it's some modern Rust microservice or an old COBOL mainframe thing. Somebody needs to take responsibility for it. Somebody sort of needs to run it. And if I run something, I do want to know what it can do, what it can't do. Yes, it's a lot of legwork. It's
Sorry, that's maybe a question, and I'll ask you that, Carol.
it's a lot of legwork. It takes probably if you've studied archaeology, it probably helps. But I do think it's important. It doesn't matter how old a piece of kit is, you still want it maintained. You know, some beautiful classic cars don't have onboard computers, but they're still, if you maintain them properly, still are very good cars. And the same is true for software. And yes, it is difficult, but I think that's the mindset that you have to have. It's not, if you have the mindset, this is legacy, I can't touch it, then you're in trouble. Yes, please.
What's your take on commercial tools with respect to the open source? So because you said legs, arms, and the children, I had this question.
This is recorded, isn't it?
We can switch it over for a second.
No. I think there's a lot of good tooling out there. There's a lot of help. Where I have problems is when people come in and try to sell you a security platform where you have to buy in and every developer has to have something, and you get charged an expensive amount. I think there are great open source tools. If OWASP still had ownership of Zap, you know, I'd say use it. I'd still say use it. But there are other tools available, and I think it's about playing with it. What works for you? What tooling works for you? And it may well be a commercial tool that gives you all the things. But you have to ask yourself the question, the commercial tool usually doesn't know your system as well as you do. So if you handing over responsibility of securing your build pipeline to a commercial tool, and you're paying for it, usually those things are quite expensive, then you know what are you paying? Are you getting value for money? But yeah, I mean, I'm not saying don't get any commercial tools done.
Buying a tool doesn't solve the problem.
No, you still have to.
And what portion of people think that's the way out?
Yeah.
There's a tool, that's
Yeah,
the thing.
it's-
It doesn't.
Yeah,
Don't know what to do.
You don't know what to do with it, for example.
or thinking, oh, I've got a yearly pen test and they gave me a tick and I'm fine. It doesn't work like that, I don't think, especially at scale.
Okay, can I just shout out now? So that brings me to my question, which is, how do you feel about wrapper tools? So wraparound tools like Rosa. So tools like Drosa that are wrapping around a number of other tools that work very much in the browser. So it's kind of putting in a number of different hacking tools into one space. How efficient do you think they are, or do you think they're useful? Like Drosa was an MWR tool, so it's probably very unsupported now. It's janky as fuck anyway. But do you think they're useful?
Sorry, I don't know them.
Moving on.
Yeah. You'll have to tell me about it later, because no, I don't know it. And I had a really lovely discussion earlier on that table about, you know, realizing that you don't know everything, making mistakes, learning every day. So it sounds interesting, or not.
We're on our last question, I think.
Yeah,
And I'm
okay.
gonna swoop in.
One more question. Anybody? Ah, we got one.
When you take the CVSS, did you get kind of a score of how catastrophic it is within the context of your business, or just
So I tend to have four categories. It's no action, under investigation, action, or it's uncurated. If there's something really bad, then I basically go and approach the team to say, look, you've got something like this, can we sort it out? And we then collaborate on sort of risking it. For some vulnerabilities, there are risk frameworks where you can sort of work out, well, what is the likelihood that it happens, compare it against the seriousness, and I think it's important that you make a sort of risk-based call, because you can't fix everything. But some things you want to be on it, like the lock shell stuff, you wanted to be really on it and ruin somebody's Christmas. A lot of people in here, I believe.
Okay, we're done, guys. That was the absolute dog's balls.